Hey guys, so with this quick lecture here, we are going to learn how to do limiting reactant problems as far as real world situations, like when are people actually using this? Okay, so these are numbers are different here to make them more manageable for our class, but these are similar to what real engineer or someone like that would have to use stoichiometry in their job. Okay, so I'm just going to walk you through this example here, and then hopefully this will make sense. So in 2010, Signa Chemistry developed an electric bike that uses water for fuel. Certain bikes use electricity to help people ride with less effort. Okay, the bike uses sodium silicide and water to produce hydrogen fuel, which is harmless to the environment. The technology won the Presidential Green Chemistry Award. Okay, so how was this bike developed here? What does this have to do with stoichiometry? So here is the thing. By the way, this is a real bike. I didn't make this up. Okay. So the bike can produce about 200 watts during a 30-minute ride with one sodium silicide cartridge weighing about 1.5 pounds. That's 680.4 grams, and 1 quart of water. That's 946.4 grams. Use the equation below to figure out which is the limiting reactant. In other words, are you going to replace your sodium silicide cartridge first, or are you going to have to replenish the water tank first? And of course, you don't want your customer to have to make those calculations, right? So when you're the engineer or the team of engineers developing this bike, you got to think all this stuff through. And this is a stoichiometry problem here. This is a limiting reactant. Are you going to run out of the sodium silicide first, or are you going to run out of the water first? Whichever one you run out of first is your limiting reactant. So, if a person's going to go on longer than a 30-minute ride, do they need to be near a water source? Do they need to take extra water with them? Or do they need to take a second cartridge? It depends, right? So that's the point of the limiting reactant calculation that we're going to do here. Now, as we work through this, the thing to note is that we have two knowns. We have 680.4 grams of that and 946 grams of this, which is water. So with our mole train, this is grams of A. This is also grams of A. We have no idea what unknown we're looking for. Guess what? We get to pick. We can look for this or we can look for this. Hydrogen looks a lot simpler than this other molecule here, so I'm going to look for hydrogen. I'm going to say here, I'm going to say grams of B. I'm going to try to figure out how many grams of hydrogen this guy makes and how many grams of hydrogen this guy makes. The one that makes less is my limiting reactant. Okay, so let's just work this out. So I'm going to set up my mole train for sodium silicide right here. I have 680.4 grams of sodium silicide, and I'm going to do 3 steps to get to grams, and I have 51.08 grams of sodium silicide to 1 mole of sodium silicide, and then 2 moles, and then 5 moles. And this is from the equation. And then 1 mole of hydrogen gas to 2.02 grams of hydrogen gas. When I do this math, the cartridge will make 67.27 grams. Oops, that's supposed to be 67.27 grams of hydrogen gas. I'm going to do the same exact thing with water. So my goal now, I'm getting ahead of myself here, is to figure out how many grams of hydrogen does my quart of water make. And I do the same exact process, except that now I'm using the molar mass of water down here to 1 mole of water. And then over here, I have 5 moles of water to 5 moles of H2. So I know that 5 and 5 cancel each other out here. And then 1 mole of hydrogen to the molar mass of hydrogen. When I do this math, I really should write this again. So this is 67.27. This down here is 106.1 grams of hydrogen. So what this means is that I make less with the cartridge, right? With the sodium silicide cartridge. So guess what? My limiting reactant is this right here. Okay, this is my limiting reactant because once I make this much hydrogen gas, the reaction stops because I ran out of sodium silicide, right? So that's how we do this problem. So if you're an engineer and you're working on the spike and you develop this, you got to tell the technical writer in your team who's writing the manual to say to the customers, if you're going to ride for more than 30 minutes, take an extra cartridge with you. The water will last, right? We can make almost not quite double the amount here, but more than 30 minutes. The first thing you're going to need is a sodium silicide cartridge. Okay, so that's how we do that problem.